Rocky. Shh. So what we're doing now, or what we will try to do, would be to figure out the point of intersection or the solution of these simultaneous equations without graphing them. Okay, so we'll be looking at two strategies. We'll be looking at one today, and then next term we'll be looking at elimination. So today we'll be looking at substitution, right? What does it mean? Well, anyone who's seen this or tried to solve these types of puzzles that they see on the social media? Yeah, right? Okay, so how about if I give you a minute or so, right, to tell me how much does a can of soda cost? 3 chips is 15, 2 chips and a burger would be 40. An order of chips, 2 burgers and 2 cans of soda would be 31. Is it 3? Did everyone get 3? How do we check if we know that 3 lots of these would be 15? They would be $5. So this one would be 10, correct? Because each of these would be 5. And therefore, each of the burgers would be how much? 10, right? So we've got 5, we've got 10 and 10. So that's 25. But then it equals to 31. And therefore, these two would cost $6, right? And therefore, Hale was right that the can of soda was 3. Who thought that was really easy and clever too? So what you did here actually would be a system of simultaneous equations without knowing, right? And this is even more than what we're supposed to learn this year, because this would actually have 1, 2, 3 variables. So think of this as saying 3x equals 15. This is 2x plus 3y equals 40. And then you've got x plus 2y plus 2z equals 31. See, you're actually doing maths. You're actually doing and solving simultaneous equations here, right? And it's more than what we want to accomplish this year, because with the simultaneous equations that we'll be talking about, look here, it would only have how many variables? You've got 1, you've got 2, 1, 2. 2 variables, all right? And when you have 2 variables, you would need to have 2 equations for you to solve them. Whilst with this one, you see how they've got 3 equations because they have 3 variables. Okay, so what we want here would be to solve the simultaneous equations y equals 2x minus 1 and 3x plus 4y equals 29. Okay, so we have these 2 equations here. You can, that's what it was saying for you to maybe mark it as equation 1, equation 2. Okay, so let's probably write that down here. And let me make that larger so that you can see my writing. So we want to solve 2 equations, y equals 2x minus 1, and that 3x plus 4y equals 29. All right, so instead of writing y here, you would want to write 2x minus 1. So you've got 3x plus 4. Because we know that y is equal to 2x minus 1, then you can get rid of the y here and replace it with an expression that would be in terms of x. Okay, so you would have 2x minus 1 equals 29. Does that make sense? So it's substituting y, right? Substituting the y with 2x minus 1. Does that make sense? We can now simplify this side so that we would be able to figure out what the value of x is here, right? Now, have a look at firstly your equations. The first equation there would have 2 variables. The second equation would have 2 variables as well. But then if you look at your third equation, how many variables do you now have? you only have just one variable, and that is your objective. Your objective would be to get rid of one of the variables so that you will be able to find what the other one is. Okay, so for us to do that, we can simplify the left side. We would want to distribute the 4 into each of the terms here inside your brackets to have what? 3x plus 8x minus 4 equals 29, right? So what I did was to just distribute the 4 to 2x. 4 times 2x gives me 8x. 4 times -1 gives me -4. Okay, now I can combine these two, adding 3x and 8x. I get 11x minus 4 equals 29. Yes? Now I want to get rid of the -4. I would do the reverse. I plus 4 on the other side. Yeah. And now I've got what? I can cancel these out. And I've got 11x on the left side, and 29 plus 4 gives me 33, which is perfect because I know 11x equals 3 means 11 times x equals 3. What did I multiply to 11 to get 33? X must be 3. Does that make sense? Now, am I done here? No, I'm not done yet, because I know that when I solve simultaneous equations, I need to have a value of x. I also need to have a value of y, right? So far I've got the value of x. You might also want to simply circle that, right? Now you've got two equations here to choose from. You can again substitute the value of x to the first equation or to the second. But looking at these two equations, if you substitute the x to the first equation, then you would be able to get the y straight away, unlike with the second equation. What do I mean? Let me write the first equation, right? And say that that's the first equation. I would want to substitute the value of x, right, which is 3, to this one. So now I've got y equals 2. 2x means 2 times x, and therefore I'm multiplying 3 to 2 minus 1, correct? And therefore I've got now what? 2 times 3, I have 6. 6 minus 1 gives me 5. And therefore I now have my solution. Just like when you are graphing or solving by graphing, you would want to write your solution as a pair of coordinate pairs, right? So you would want to write down the value of x first, which is 3, and then the value of y, which is 5. Another way to write down your solution would be you say x equals 3 and y equals 5. So this time, this is my equation 1 and this is my equation 2. But this time I will have to substitute what? Equation 2 into equation 1, right? So instead of writing x, I would have to write -3 minus 3y, right? So then that's 3, -3 minus 3y plus y equals 7. And I would have to distribute the 3 to each of these. I now have -9 minus 9y plus y equals 7. Yeah. Now solving this equation, I can combine these two. I have -9y plus y. That gives me minus 8y. So that's -9 minus 8y equals 7. Yeah. And getting rid of the -9 is adding 9 to both sides. And therefore, I have minus 8y equals 16. And y, therefore, is equal to -2, because -8 times -2 gives me a positive 16, right? So now, again, I would want to circle that and replace the value of y into the second equation. I can do that here too, but then it doesn't give me the value of x straight away. Okay, so I would now want to substitute y equals -2 to this one. So I have x equals -3 minus 3y, substituting the y that I got, minus 3 times -2, right? And therefore I've got x equals -3. What's -3 times -2? That would be +6. And therefore x must be 3, right? And again, how do I write my solution? I say 3, -2, or a better way to do that, you say x equals 3 and y equals -2. Okay, yes. How did I get -8? Where is it? Oh, here. This one. How did I get this one? So it's from here, you've got -9 plus 9 is 0. So what's left on the left-hand side, it's -8y, right? And then 7 plus 9 would give me 16. And -8 times something gives me 16. What's that something? That something would be -2. Does that make sense? It's this one here. Did you get that? Okay, thank you. All right. Now, that's all right. Now, let's discuss now that last example there. I skipped it and gave you one other example because question 5, or the example 5 here, which is our example 3 in our discussion, sometimes a lot of students would get confused with these like equations here because both y would be isolated. So you'd have y equals 5x minus 8, y equals -3x plus 16, right? Why do they get confused? It's because both equations 1 and 2 look like you can substitute this expression to that, or that you can substitute this expression to this, right? But what do? You can actually say, you're saying, let's say this is A equals B, correct? And then you say A is Y, A equals something else, A equals C. What can you say about B and C? What you can say is that B must be equal to C, right? Yes, if A equals B and A equals C, the only sensible thing that you can say about B and C would be that they are equal. How do we apply that? Then if you're given y equals 5x minus 8 and y equals -3x plus 16, what can you say about these two expressions? That they are equal. So your next step there would actually be to say that 5x minus 8 equals -3x plus 16. Does that make sense? Right? This is B, that is C. They are equal because you're saying that A equals B and A equals C. Therefore, you're saying that these two expressions are equal. Does that make sense? Yeah. So now we've got this third equation. Now we've got x on both sides, right? We want to get rid of the minus 3x here. How do we get rid of that? We add 3x on both sides. Now what do we have? 5x plus 3x gives me 8x minus 8 equals, that's 0. And you have 16 on the right side. Yeah. Now you want to get rid of this. You add 8. Add 8. And therefore you've got x equals -8 plus 8. Shh. Training, you can't go out. The grass is wet. -8 plus 8, you get 0, so that cancels out, right? And you have 16 and 8 giving you 24. 8x equals 24. 8 times something gives you 24. That something must be 3, right? And now you're lucky because then your equations, you can pick any of them, right, and substitute the value of x. But looking at this one, I would probably rather this one because then that's got a negative there, right? So then I'll pick the first equation, y equals 5 times 3 minus 8. That gives me y equals 15 minus 8, which now gives me y equals 7. And now writing my solution, that is 3, 7, or that, to make it clearer, I'd write that instead. Does that make sense? If you're stuck with any of the questions here, let me know. I'll be online and answering your questions. Okay? All right. Thanks, everybody. I'll see you next term. Please stay safe, stay well, and stay awesome. Bye.
Come on, Rocky, let's go.